Thank you. Thanks, guys. Thank you. Thank you very much. Thank you so much. I am delighted to be with you guys. Thanks so much for coming. I am a scientist and am a professor, so that means I get paid to ask questions and try to find answers to those questions, because that's what a scientist does. But I have the unique pleasure of also being a professor, which means I get to teach some of these things. And it's in that role, in fact, it's both of them that brings me here today, because not only am I teaching you some of the best principles with regards to metabolic science, but I'm also going to share with you some very new data. So we're going to get into some science talk at the end. Now, this is a new message. Some of it will be familiar, because what is so common about me ever coming to a Unicity event is the opportunity to talk about metabolism. So some of it will be familiar, and then we're going to get into some pretty new stuff. But it's still stuff that I'm very competent to speak about. So don't fear that I'm getting outside of my area of expertise. No, my area of expertise just includes more than you think it does. So here I am about to teach you some new ideas. So the topic is muscle matters. We're going to focus a lot on what's more accurately called skeletal muscle. There's actually different types of muscle in the body, but the one we're focusing on is a skeletal muscle. So I'm going to help you understand why muscle matters when it comes to metabolism. Okay, you already are aware of the fact, but constantly, what I'm hoping when I give these kinds of lectures is that I've conveyed an idea to you, and you can then convey that idea to someone else. I want you to then go be a professor. So one of the most important points that you teach your friends is that insulin resistance is the most common health disorder in the world. That is why I've devoted my career to understanding it. Insulin resistance matters most when it comes to chronic disease. So not only is it the most common health problem worldwide, but as I noted, with regards to chronic disease, the most common killers are in some way derivative of this metabolic problem, or to say that another way, they share a common metabolic origin. But beyond these lethal diseases, we have some inconvenient and sometimes heartbreaking ones, where even the most common forms of infertility are also influenced by insulin resistance, whether it's erectile dysfunction in men or polycystic ovary syndrome in women. They once again have this in common. And then we could even go to the brain, where there are myriad brain disorders, through memory problems to mood problems and everything in between, that also share this insulin resistance. Now, let's trim it all down and just talk about the metabolic problem, where insulin resistance, its most obvious eventual outcome is type 2 diabetes. So let's just bring in a bit of a new paradigm, and not one that I share very often here, if ever. Now, the average individual comes into their physician from time to time, and they've been getting their fasting glucose levels measured over the years. That is a marker that is always going to be measured. And then we see that eventually their blood glucose levels start to climb. And that's when an individual would get diagnosed with type 2 diabetes. However, this chart is currently incomplete, because as much as we have a very glucose-centric paradigm of metabolic health, we actually need to have an insulin-centric paradigm, because it looks very different. If we superimpose insulin on this same timeline, a person over the years that we've been tracking their glucose, if we now include a measurement of insulin, you can see that insulin has gone up well before the glucose has gone up. It's gone up decades before the glucose has changed. And so you can see there are, if you will, two very important time points. This first time point is where we hope we can intervene in someone's life, because it's just so much easier to reverse course as they've been descending metabolically through the levels of purgatory into metabolic hell. It's easier to get them back up into heaven a little sooner before they've gone too far. So this early stage is insulin resistance, also known as pre-diabetes. But eventually, when the glucose levels start to rise, then we say that the person has transitioned, they've graduated, or better, to go back to my earlier metaphor, they've descended into a lower level of metabolic purgatory. I'm going to come back to this view in just a moment, because what most people don't know is what flips the switch. What actually turns the person from being in insulin resistance into full type 2 diabetes. It's important. Okay, now, before we get to that point, let's still focus on insulin resistance for another moment. After all, it is the most common health problem worldwide. So where does it come from? The most common cause of insulin resistance is too much insulin. So this makes it a very obvious lifestyle factor, where the more a person is living a life where their insulin levels are elevated, then the more the body starts to become resistant to that insulin. This is fundamental. It's a fundamental biological principle. In biology, too much of something will cause a resistance to that something. This is why antibiotics need to be used so judiciously. This is why cancer drugs, chemotherapies, need to be mixed and used carefully, lest the cells start to become resistant. And the same thing happens with hormones as well. Whether it's too much insulin causing insulin resistance, whether it's too much leptin driving leptin resistance, or even thyroid hormone, I could go on. But I'll stop, because this is not an endocrinology lecture. But I wish it were almost, because I like that topic so much. So too much insulin is the main driver of insulin resistance. But where does the too much insulin come from? It has its own stimulus, and its most powerful stimulus is blood glucose. When blood glucose rises, insulin will rise. And in this case, lest it sound like I'm describing insulin as a villain, insulin is also a hero. We need it in order to survive. God put the insulin in these bodies for a reason. Who am I to blame all ills for it? It's just too much of a good thing. So bringing it back to this topic, when blood glucose is too high for too long, that actually can become acutely lethal. It could kill a person because of changes to the kidney. And so insulin senses this spike in glucose, and it comes up from the pancreas through the body, and it starts opening doors. I'll come back to that idea in just a moment. But this leads me to say, well, the most common thing driving our glucose is our constant carbohydrate consumption. Now, many of you have heard me talk about this before. I don't mean to wage war on dietary carbohydrates, but if we look at the food we're eating and then we say, okay, which is going to spike my insulin the most and keep it elevated the longest? Well, of course, one stands supreme. But it also stands out because we just eat so much carbohydrate. Globally, roughly 70% of all calories come from dietary carbohydrates. That is massively skewed in favor of one macro. And then, as I alluded to a moment ago, this becomes all the more sobering when we appreciate what these macronutrients do to insulin. When a human eats pure protein or fat, there's little to no spike, as you see here. And this is based on human data, what you're looking at now. But when a human eats pure carbohydrate, there's an enormous spike. Insulin will go up 5 to 10 times, and it will take about 3 hours for it to come back down to normal. All right, so we want to control our carbs. Okay, now let's get into some new discussion here. So I just showed you that this is what happens to insulin when a person eats pure carbohydrate. But this is not a measurement of blood glucose. And as much as I just said we focus too much on glucose, we still have to consider it when we want to understand what insulin is doing. So if we now bring glucose back in, now please appreciate the view that I'm showing you now is a momentary view. This is when a person eats a load of carbohydrate. This is not the year-over-year perspective that I showed you earlier. This is you drink a load of glucose or you eat something starchy and sugary. Now we measure what happens for the next few hours. So you can see that the glucose has the massive spike up. It can go up 2 or 3 times in a person, and then it'll take 2 to 3 hours before it comes back down. Now you'll notice that I deliberately show that drop. That's an important point, and I kept that point here to share a principle with you, which is that deep little valley, what's called a rebound hypoglycemia, is a primary drive for hunger. So when a person eats something or drinks something starchy and sugary, they have just put in a lot of calories into their body. And yet within 2 hours or so, they find themselves wanting more. Well, that's not possibly because you've run out of calories. In fact, I'm a fairly lean guy, and I have on my body well over 100,000 calories stored in my body right now. I don't need to eat 2 hours after I just got done eating something, but the brain doesn't know that. So this is a topic for another time, but so much of how the body regulates appetite and hunger isn't a matter of how much energy is stored on my body. It's actually what are the signals going to my brain. And in that moment, at around that 3-hour mark where the glucose drops, the brain starts to panic because it, in that moment, doesn't know that there is hundreds of thousands or even millions of calories on the body waiting to be used. It thinks we're starving, and so it wants you to eat more to push that glucose back up. So just on that one thing, and I've already gone on much longer on that point than I intended, to avoid those, to prevent those drops, avoid the highs in the first place. Don't let yourself get so high and you won't go so low. So you want to level that out. You have, of course, very good ways to do that, which I've talked about in previous talks, including chlorogenic acid and theobromine, which can help with acute glycemic excursions, and of course, so too can balance. But I've talked about that before, and you need something new, so let's not revisit the past. Okay, so look at the glucose coming up, and then look at it coming down. Where does it go when it comes down? That's what I want to teach you just for now, before we move on. So let's look at the body. Where's that glucose going? Well, you could say, well, Ben, it's going to the brain. Yes, some of it is. And the brain, after all, is a high metabolic rate organ. There are 3 tissues in the body, by the way, that are considered, like a holy trinity of high metabolic rate organs, where their metabolic rate is just so different from every other tissue. The brain is one of the 3. I think it's number 2. And so you'd say, well, it's going into the brain. Well, yeah, but the brain isn't that big. Within the animal kingdom, it's really big relative to other animals, but within the entirety of the body, it's not that big. So by mass, it doesn't consume that much. So that's not it. What about the kidneys? Because I know what you're thinking. You're thinking the kidneys, after all, Ben, as you're thinking this, have the highest metabolic rate of every tissue in the body, and they do, and it's not even close. Isn't that interesting? If you're ever wondering about metabolic rate in the body, the kidneys are like 10 times higher than any other tissue. They are so busy all the time. Just as a funny little aside, when my lab has measured metabolic rate in kidneys, it's so fast that it actually we have to change our entire protocol because the metabolic rate is so much faster than any other tissue. But even then, it's not the kidneys. Most of it goes into your muscle. 80% of the glucose, that as you see the glucose levels coming down, let's say you're wearing a continuous glucose monitor or something. You see the glucose come up, and then the glucose comes down. When it's coming down, 80% of that glucose is going into your muscle. So we want to make sure that our muscle is working well. Now let's come back to that paradigm that I showed you earlier. What is at least partly responsible for flipping the switch, driving someone from insulin resistance into full-blown type 2 diabetes? Part of it is that the muscle becomes insulin resistant. In fact, it's a very big part of it because 80% of our glucose goes into our muscle after we eat it, the glucose. And insulin is a big part of it. In fact, let's talk about that in a little more detail. Some of what I'm going to show you is actually some of the tests we do in my lab when we want to measure insulin sensitivity and glucose uptake in muscle. We actually take advantage of the very process that I'm going to teach you now. So here we have muscle tissue, or an individual muscle cell, commonly just called a muscle fiber. In fact, I'm going to show you a picture of a muscle fiber at the very end of my talk in some of the tests we did. So that'll be me being a scientist rather than a professor. All right, so here's the muscle. Like every single cell in the body, muscle has what's called an insulin receptor. It's a little doorway that's just designed for insulin to come and knock on. And again, every single cell of the body has insulin receptors. It's one of the reasons why insulin is so relevant to every tissue. All right, now when insulin is flowing through the blood, it comes and knocks on that door of the muscle. And then I'm just going to say that the muscle has an action because it does a lot. Insulin does a lot of things at a muscle cell, and it does even different things at other cells. But the most famous effect is that it will open these doors called GLUT4. Now, some of you are thinking, why is Professor Ben talking about my buttocks muscles? I don't mean your glutes. I don't mean those perky little muscles on your backside, which is another thing that makes humans very unique, by the way. Other animals don't have these big chubby muscles on their backs like we do. But anyway, so I'm not talking about glutes on your bum. I mean glucose transporters. Glucose transporters, there are a lot of them. I think most recently there are 14 that have been discovered, but GLUT4 is unique because it will only open when insulin comes and knocks and tells it to open. But the muscle is loaded only with GLUT4. So insulin knocks, GLUT4 opens, and of course, what's all that glucose going to do, those little G's and the hexagons? Then the glucose is going to come in, thereby lowering blood glucose to where the insulin wants it to be. Now, as I mentioned, though, insulin does a lot more than that. Insulin is in charge of all nutrient metabolism, whether you're talking about lactate, which is a calorie that tissues can burn, whether it's ketones, fats, amino acids, glucose, insulin will manage all of it. So nutrient metabolism, cellular growing and shrinking and death, autophagy. Some of you who are interested in fasting, you've heard about autophagy. Insulin controls that too. Even electrolytes, like potassium balance, is fantastically affected by insulin, and much, much more. All right, so to this point, one key takeaway that I want you to get is that muscle is critical to insulin sensitivity. When muscle is working well and we have enough of it, glucose is going to go into that muscle more readily. And the more we can dispose of the glucose from our blood into our muscle, then the lower insulin levels can be. So when we have good muscle mass and function, insulin's going to be lower. And of course, as you recall, high insulin is what drives insulin resistance. So the more we can put the body, or the more we can adjust the metabolic milieu to help insulin be down, the more we're improving insulin sensitivity. Now, however, what we can have is that muscle mass is reduced, and the more muscle mass is reduced, the less disposal sites we have for the glucose. Thus, the blood glucose will be higher, and the more blood glucose, and the less there is for insulin to be able to do effectively, so we need a lot more of it. Insulin isn't working as well. So less muscle mass in a person. If you took this form of Ben and stripped me of my muscle, and you would say, well, you'd have nothing left because you're all muscle, right? It would be a pile of freckles on the ground. Yeah. So you strip away, let's say I lose 10 to 20 pounds of muscle. And then now you gave me that same load of glucose, it will take me much longer to clear that glucose because my muscle is so hungry for pulling in that blood sugar. So muscle mass is critical to insulin sensitivity. Now, I also want to show you a different view of the muscle. Because the muscle needs to maintain its size and its mass. Because what makes the mass is this balance of amino acids that come into the muscle cell or the muscle fiber. In fact, just as an interesting principle, let me teach you guys. When we grow muscle cells in a culture dish, in a little petri dish, they are multinucleated. So one individual muscle cell will have multiple nuclei or nucleus. And I know what you're thinking, which is you're saying, Ben, that's impossible. Cells just have one nucleus. Yes, you're right, good job. But what's unique about muscles is that it will take these early muscle cells and start fusing them together. So one little muscle cell will start fusing with other muscle cells, not only creating a fiber, but then merging all of their nuclei. And so it's a multinucleated cell. I don't know why I even went on that little rant, but now you know a little more about it. Now, when we think about the muscle, though, we have to consider the amino acids coming into the muscle, allowing it to grow, because those amino acids will turn into muscle proteins. And it's the muscle proteins, as I'm going to show you in a moment. I actually debated, but I'm going to teach you the principle of how muscles even contract when we flex them and relax them. But these amino acids will come into the muscle. They will form into the muscle proteins, but those muscle proteins are not invincible. We can break them down, and then you have the muscle cell releasing its amino acids. So as you see here, the size of the muscle is going to be a balance between the amino acids coming in minus the amino acids going out. That is the entire algebra or the entire calculus of the muscle cell. Okay, so I'm going to now teach you, I'm flipping this around a little bit because now I'm saying that insulin is critical to muscle mass. Now here is something you must remember lest you confuse your friends and family by stating incorrect principles of muscle cell biology like so many people do. Many influencers and even bodybuilders and people that are only prioritizing muscle, whereas we're prioritizing, yes, muscle, but also brain. Brain and brawn is what we want after all. They will say that insulin is promoting the uptake of the amino acids into the muscle, and that does not happen. There have been some beautiful, and sometimes in science we say elegant studies that have been done to prove that idea wrong. So do not say insulin promotes amino acid uptake. That is not accurate. What is accurate is that insulin does promote the muscle to be big and juicy and healthy, but it does so by inhibiting, let me go back, I don't want that yet, by inhibiting the breakdown of the amino acids. So insulin is lowering the amino acids coming out rather than promoting the amino acids coming in. Does that make sense? So it's inhibiting the breakdown rather than promoting the building up. All right. Now, however, the problem comes in the form of insulin resistance, where when the muscle tissue becomes insulin resistant, again, because of too much insulin as a primary driver here, but some of you would have been at a talk I gave in Las Vegas a year or so ago when I talked about stress. Stress actually also will promote insulin resistance in muscle cells, but regardless of the cause, if the muscle cell starts to become insulin resistant, then it is going to start losing insulin's protective effect. Now you're breaking down the muscle protein too readily. That, you guys ready for a multi-syllable word here that I want you to remember because it will make you sound clever and you will be more clever? That is a process called proteolysis. Proteolysis, anytime in biochemistry you hear the term lysis, it means breaking something down. Like lipolysis is the breakdown of fat from fat cells. Proteolysis is the breakdown of protein. So insulin, when it is working well, inhibits proteolysis. But when a muscle tissue has become insulin resistant, now you have removed the inhibitory effect of proteolysis from insulin. I'm saying that in a too wordy of a way. Insulin is less able to block proteolysis. And so now the muscle is breaking down its protein, even though insulin may be high, even though insulin may be trying to stop that from happening and tell the muscle to hold on to it all, the muscles become insulin resistant. All right, so coming back to that earlier paradigm. So muscle is critical to insulin sensitivity, and then insulin is critical to muscle mass. But remember, it's not because it's directly promoting a growth in muscle protein, but because it's blocking the breakdown of that muscle protein. This paradigm here is partly what is leading to what's considered one of the new epidemics. I know we all shudder when we hear that word with recent lockdowns, but we're in the free state of Florida, so we don't have to be afraid of such arbitrary lockdowns. But here, this is something called sarcopenic obesity. Sarcopenic obesity is this paradoxical confluence of these states, which you didn't used to see together. If you saw someone once upon a time with obesity, the sheer act of moving that bigger version of their body around usually resulted in more muscle. So usually more fat mass was associated with higher muscle mass, helping the person just continue to live life and get up and move around. The term sarcopenia is one that you should remember. It's a good word. It's a nice term that describes the reduction in muscle mass. That is what sarcopenia means. Sarcopenia, reduced muscle mass. So now we have this weird, as I said, paradox where you have people who are both wasting their muscles while promoting fat mass. That is, if you'll pardon my French, a hell of a combination. One we do not want. All right, let's come back to insulin resistance then. Now, in fact, even though I say that, this is a painful moment for me, because while I would love nothing more than to just talk about insulin resistance forever, there is another type of resistance that is very relevant to what you do in your jobs, which is helping people feel great. And that is this very related, it's a sibling to insulin resistance called anabolic resistance. Some of you have already heard of this. You've already been talking about it. I want to just share my own view and then what you can do and how these things relate to one another. So anabolic resistance is this unique state of the muscle. Now, here are some other words to just appreciate and remember. One is just what anabolic even means. To appreciate that, we have to appreciate what the term metabolic means. Metabolism is this term of chemistry or biochemistry which refers to the anabolism, or the building up, balanced with catabolism, or the breaking down. So anabolic reactions are reactions within a cell that takes simple molecules and starts building stuff out of them. It's like the one individual piece of Lego, and now it's becoming part of something bigger. But the catabolic reactions are the naughty little toddler who comes and smashes all those connected pieces into a bunch of small pieces that you will step on at 2 a.m. So here we have the balance of anabolic and catabolic. With anabolic resistance, we start to see in individuals that they become less capable of building and retaining muscle mass. So we are making less protein from amino acids, and we're breaking them down too readily. So we have too little synthesis of the protein and too much proteolysis. So we have too little amino acids coming in and too much amino acids going out. So the balance is not favorable with anabolic resistance. And remember, so much of this matters beyond just the glory of having a lot of muscle and dunking a basketball or posing with a shirt off for a photo. Muscle is so important, remember, because it is that metabolic master. It wants to consume the glucose, and so it acts as a tremendous buffer to help our blood glucose levels be more stable. That's the metabolic view where we defend more muscle, why we want more muscle. Now, the type of person who's going to have more anabolic resistance is usually going to have two distinct attributes. He's going to have insulin resistance, and he's going to be older. Now, those are not the same. They don't need to go together, thank goodness. Those of us that are getting older, they don't need to come together. But the older you get, even if you're insulin sensitive, you will have a higher degree of anabolic resistance than your younger counterpart. That is just a feature of aging. Now, that doesn't mean it's hopeless. In fact, you are uniquely suited to give this person more hope, as we'll get to in a moment. And then, of course, on the other end, it's someone who's younger and someone who's insulin sensitive. Those are going to be the two key attributes that explain or help us understand why a person's going to be more anabolically sensitive. They're more responsive to the growth signals and have an easier time building and retaining muscle. All right, so insulin resistance matters tremendously. And just at the risk of repeating myself, just remember, these two types of resistances really play off of each other. The more the body is becoming insulin resistant, or the more the muscle is becoming insulin resistant, the harder time it's going to have helping the body be insulin sensitive because it can't control blood glucose as well. Then at the same time, the more anabolic resistance a body is experiencing due to age or lifestyle variables, the smaller the muscles will be, and the less mass, the less of a consumption of glucose there is, and thus the body will be more likely to have insulin resistance. So this becomes a vicious cycle. Now, on the insulin resistance side, pardon me for saying this, but you guys are very well suited in order to help people take care of that. That is something you've heard me talk about previously. The Feel Great system, if I may say so, is really well designed to help people address their insulin resistance. So you've got that covered. And I'm just reminding you of things I've talked about before, and I will not repeat myself. But when I usually talk about these principles and the utility of Unimate and balance, I often focus on helping someone control their consumption of carbohydrates and control the glycemic excursions that come from that consumption, and then two, how to fast more frequently. So whether it is the bitter tastants like the theobromine helping control appetite sensors in the brain or in the intestines, or whether it's the chlorogenic acid or the short-chain fatty acids from the soluble fibers that help control the glucose excursions, when it comes to you helping people improve their insulin resistance, you are in a great spot, and you've got those tools locked in. But now I know what you're thinking, which is, but Ben, what about the anabolic resistance? Even there, now, you have something that has been specifically designed to help you with it. Yeah, good, clap. It is something worth cheering for, because you haven't had a great or targeted solution until now. Yes, there's something you could talk about. Yes, there's been nice proteins available in the past, but as a person who you can't tell, and I don't mean that too self-deprecatingly, but I absolutely prioritize muscle mass. That is something I focus on. I've joked before, some of you have heard me say it, that as part of my unofficial marriage contract to convince dear Cheryl to marry me once upon a time, it was very clear that my beautiful red hair was falling out quite quickly, and that soon I would have the shiny head that my dad has, albeit with some more freckles than he has. But I knew that that was the path. But I told her, I said, dear Cheryl, I can't do anything about this, but I will sure as hell do something about this. And so she will be the judge of how well I've done that. But suffice it to say, I very much have prioritized muscle mass retention just because I want to be a healthy dad. I want to be a very, very healthy grandpa someday. May God bless me with many, many grandbabies. But that day will come, and I hope that my muscle will be up to the challenge. So now with Stronghold, it's a great name, isn't it? You really do have something in your toolkit to help your friends and family. When you start introducing this idea of, hey, Feel Great has been directly helping you improve your insulin sensitivity, but we have this underlying, a foundational part of you that can also be helping every moment of the day or night, whether you're sitting or standing or running or anything else, and that's your muscle mass. So Stronghold is designed to help you overcome anabolic resistance. All right, now let's talk about it. When I started thinking about principles that I would want to teach to enable you to teach someone else, I thought that there were 5 things to talk about, actually based on 5 parts of what has gone into Stronghold. First, one is superior protein. Not all protein is the same. Not all protein is equal. And when we look at dietary protein, we do want to look at it at the level of the muscle. We want to say, what I'm putting in my mouth, what can I do to get that into my muscle? In fact, the harder that is to put what I'm eating in, getting into the muscle, that is perhaps the simplest description of anabolic resistance. Anything that is compromising the ability of taking these amino acids or this protein that I'm eating, protein after all, to go way back, when you eat protein, part of digestion is to snip those proteins apart into their individual amino acids, or at least a couple amino acids together. So you get down to these base units. That's why I'm talking about amino acids and not protein, because in the blood, it's not moving as protein, it's moving as amino acids, just as a foundational aside here. So when we look at superior protein, we want to do whatever we can to get that protein into our muscle. And with anabolic resistance in mind, remember, that is the person who's older and or insulin resistant. So even a young teenager who's insulin resistant is going to have some degree of anabolic resistance. It's going to be harder to turn that protein into this protein of our bulky muscles. All right. This study, and remember, I always have those little PubMed IDs in the bottom corner so you know that I'm not making stuff up. They found that with superior protein, even in older adults with anabolic resistance, in fact, let me rephrase that. The more a person has anabolic resistance, the more important the quality of the protein becomes. The more anabolically sensitive you are, the more you can get away with what I would maybe call garbage protein. It doesn't matter as much. Your body is so capable at turning this amino acid into this protein. But the more anabolic resistance you have, the more it's important to get the best. So this was designed with the best in mind, where it has been shown to increase in humans in a doubling of the amino acids in the plasma and an almost 50% increase in what's called muscle protein synthesis. And I just have that abbreviated as MPS. So muscle protein synthesis went up by about 50%, even in people with anabolic resistance, by giving them a superior protein. So protein matters, and it matters a lot. So we picked the best protein and we put it into Stronghold. Okay, now what else? The second one are two parts of protein that we actually leaned into, where we increased it beyond just the normal amount because they are so important. And that is the branched chain amino acid leucine and one of leucine's metabolites, hydroxymethylbutyrate, or sometimes just referred to as HMB. Now, these are separate molecules. And not even the degree to which leucine gets converted into HMB is very modest, and in some people it's even more modest. It'll only be about 10% of the leucine. We wanted more HMB because these both work together. Leucine is the most powerful amino acid that promotes anabolic muscle protein synthesis. Of all amino acids, leucine stands supreme. And then an HMB will do that as well, but leucine is the strongest individual amino acid signal. But HMB will also promote that growth of the muscle, so it's a really good sort of intake for the muscle. But we also have this anti-catabolic aspect where HMB is a very powerful anti-catabolic signal. It inhibits the proteolysis. So it's telling the muscle, hey, muscle, we just got done building up a bunch of protein. Keep it there. Don't start breaking it down. We want to lock that in. HMB really helps lock that in, especially in older adults. All right. In fact, that's this point here, where HMB is uniquely good at overcoming the proteolysis that just predominates during anabolic resistance. You guys, as I just said that sentence, I just had a thought that I'm using a lot of words that might be kind of new. Are you following me pretty well? I want you, I don't mind if the vernacular of a talk makes you reach a little bit because you'll be better for it. But I don't want to go too far. So if you've had to start creating a little glossary on your notes, the more you can incorporate some of these words like proteolysis and catabolism and anabolism into your story, the more the person listening is going to want to know what you just said. And so it puts you in a really, really good position. So I want you to reach a little bit, but I don't want it to be too far. But you're good. Yeah, you are straight A students. I know. I love it. I love it. Okay. But it is fun. As I always joke, it is so fun to teach a group of students who actually care, where mom and dad just aren't paying their tuition. And they'd rather be looking at some stupid social media post. And I'll be standing up in front of my kids thinking, do you know how lucky you kids are to be listening to me right now? Not because I'm so good, but because the topic is just so cool. Yeah, so you're lucky. As a reminder, thank Unicity, because you have to hand it to them. I don't know of any other group like them who actually invites working, living, breathing professors and scientists to teach these kinds of things. It is so unique. It is awesome. Yeah, it is awesome. It is so fun. I can speak for all of us boring PhDs. It is so fun to have students who actually care. All right, so let's still stay with these two, leucine and HMB, because there's a lot more to teach you. And one important thing is for you to become familiar with a protein signal within the muscle called mTOR. mTOR stands for, just so you're aware, not that you need to remember this, it stands for mammalian target of rapamycin. It's one of these weird proteins that was named because it was identified based on the use of a particular drug. So they had a drug called rapamycin. Don't get me started on that drug. A lot of you are thinking of longevity. Boy, I could go on about that. So with rapamycin, they found that when they treated cells with this particular drug, rapamycin, one protein really responded, and it is what they called a target of rapamycin. So it's mTOR. I think these things stay better on their heads when people have more hair. But who would want hair? God made few perfect heads, and on the rest he put hair. Okay, let's keep going. I got more to say. I'm taking too long. You guys got to keep my trend. I need you to start giving me a signal when my jokes are going too far. Okay, so we have mTOR. mTOR is the master signal when it comes to promoting muscle protein synthesis. When mTOR goes up, muscle protein synthesis goes up. So you want to know about mTOR, you want to be able to talk about it, and you want to know what turns it on. Well, leucine and HMB turn it on like nobody's business. And when mTOR is turned on, not only does it know what to do with the amino acids coming in, namely stack them up into the muscle protein, but it also blocks the proteolysis. It doesn't want the muscle to be breaking down. So when you can activate mTOR, especially in these cycles, like the nice thing about leucine and HMB is it turns mTOR on and then it will stop. Because oddly, if there's too much mTOR turned on all the time, it actually starts to become resistant to its own signaling. So you want, leucine and HMB are so smart together because it will turn mTOR on really, really well and then turn it off, lest the cell start to become deaf to that signal. All right. Last important point here is that HMB is so good at inhibiting catabolism or proteolysis that it will even inhibit proteolysis during a fast. So a lot of people will say, well, I can't fast, I'm going to lose muscle. It's not that simple, first of all, but even if they lead with that concern, because we do have a culture of promoting healthy and strategic fasting, well, then we could say, well, hey, then look, if you're worried about the protein loss during fasting, which again is overinflated, but even still, HMB is known to maintain this overall state of muscle protein synthesis even during a fast. Okay, next one, number 3, vitamin D3. There are multiple forms of vitamin D, vitamin D3 being the most bioavailable and used form in the body. I know what you're thinking. Ben, we're not talking about immunity. Vitamin D3 is involved in that. We're not talking about calcium metabolism. Vitamin D3 is involved in that. No, we're talking about muscle. But what is so cool about vitamin D3 and why it's so smart for it to be included is that it amplifies leucine's signaling. In fact, if you couple vitamin D3 with leucine, it can, as you see here, it sensitizes that mTOR. Don't worry about all the rest of it. I wanted to use the direct quote. And so it's some busy language here because scientists, boy, if we get good at one thing, it's had to take a simple sentence and make it into a really long, stupid, busy sentence. But it enhances the anabolic signaling of the leucine. In fact, this study found that it increased muscle protein synthesis by 14% just adding vitamin D3. Okay, now I'm taking way too long because the next thing was so cool that I created a tangent, and now I'm debating on how much time we have, so let's just keep going. So creatine. You guys have all heard of creatine. Yes, creatine is included in Stronghold because it is so worthwhile. Anytime you start talking about cellular energy and muscles especially, you want creatine to be a part of the solution. Now, in order for you to appreciate creatine, you have to take a little mini lecture from a bioenergetics PhD. My PhD was bioenergetics, which is the study of energy in organisms. Not like the thermodynamics of a physicist, A physicist is going to study the energy in, say, a steam engine, which incidentally is the whole birth of the whole idea of thermodynamics. It was to build a better steam engine. We're not steam engines. We're a little more complicated. And so I study the energy of the human body. And I don't mean like chakras. I mean like actual biochemical. And I don't want to, I'm not that kind of scientist. All right, so, but what you need to get from this is an appreciation of ATP. So you could take any cell in the body, and in order for that cell to have energy to get its work done, a muscle cell is contracting, a neuron is sending a signal, the intestines are moving the food through the body. Every cell is in the body because it's serving a purpose. It's working as part of the whole factory of the body. So you take an organic molecule like fats or glucose or ketones, you break it up, and part of what you're going to get, as you'll see, is some ATP. And this is what ATP looks like. It's an adenosine base with three phosphates linked together as a little bit of a tail. And it's this molecule that allows a cell to work. And like I just said, the muscle flexing, the neuron conducting, etc. And when we break that energy molecule, if you will, we actually do it through a process called hydrolysis, where one little molecule of water will come in and snip that last little phosphate off. Now that molecule is going to let a cell do some kind of work. Now, just as an interesting little aside here, as I've had multiple, you'll see that little logo on the Stronghold. Do some of you already know what that is? That is what's called a sarcomere. So if we zoom into a microscopic, in fact, beyond what you could get in a normal microscope, you'd have to use an electron microscope, you would see what's called the sarcomere. This right here that I show you on the left side is this image of what's called myosin and actin. And that is when we are eating protein and it turns into amino acids, and then the muscle cell will pull those amino acids in to turn them into muscle protein. Those are the proteins. When you are building your muscle cells, it's because you're getting more actin and myosin proteins stacking up, strengthening the muscle, but also expanding the volume of the muscle cell. When you contract a muscle, so as I am flexing this arm, my muscle fibers are all getting short. It's actually because, as you look at that picture, the little pink myosin fibers are coming and binding the actin and cycling. It's what's called a cross-bridge cycle. It will come up and bind it and crank on it and crank on it and crank on it. That entire action of cranking the muscle fibers together and shrinking the sarcomere is something that is very ATP dependent. So when you want to contract and relax the muscle, you need a lot of ATP. And now you're saying, well, what does creatine have to do with that? Well, creatine, when you take in creatine, it will turn into something called creatine phosphate. And it will rapidly restore that ATP molecule. So the more you're breaking ATP down, like just say for the sake of a muscle contraction, the more creatine you have, the more creatine phosphate you'll have, then the more rapidly you are regenerating your ATP pool within the muscle cell. And I say muscle cell, but in fact, we could also say brain cells, because creatine has also some of the newest evidence. We have known for decades that creatine supplementation can enhance muscle power output and recovery, which makes it very well suited for Stronghold, but it also does the same in the brain. And some of the hottest research going on now is looking at how creatine is a brain energizer as well, helping improve cognition and mitigating the effects of sleep deprivation. But also, one last comment on this, creatine also increases genes that are involved in the promotion of muscle protein synthesis. So beyond providing the muscle with energy, creatine literally activates the synthesis or the expression of genes that will promote muscle proteins. So that's MyoD1 and myogenin. Creatine will turn those on. All right, now for the sake of time, malic acid actually is something interesting. It's used often as a flavor enhancer, but even then, we choose a deliberate flavor enhancer because it also, just for making a longer story short, it helps the mitochondria actually burn more energy and has been shown to be a performance-enhancing benefit. So even the malic acid is involved. Now, some of you are going to be really clever. Well, you're going to start mixing. You're going to become little alchemists you're going to try to take these two things that are really good and make something even better, a little bit of synergy in the cell. And so you're going to start mixing Stronghold and Unimate. I'm not advising for or against this, but there's something you should know when it comes to the complexity of human biology. Chlorogenic acid is, of course, a primary component within Unimate with myriad benefits that I and others have talked about previously. And whey protein is part of the superior protein within the Stronghold. These two have an interesting relationship. On one hand, it's favorable. On the other, it's a little abusive because when you take them together, while you will enhance the absorption of the protein, you actually reduce the absorption of the chlorogenic acid. And so it's kind of like chlorogenic acid takes one for the team. You're still getting some, but you could say, well, I'm willing to lose a little bit of chlorogenic acid to get a little more whey. I just want you to know there's an interesting dynamic at play when it comes to these. Now, up until this point, I have been your professor, but I'm also a scientist, your friendly neighborhood scientist at that. So let me share with you some of our results from my lab in a new science alert testing some of the signaling of Stronghold. These are unpublished results, so they haven't gone through peer review yet. But what we did was break this up into 2 time points. The acute stimulus to Stronghold, so a one-time consumption versus a multi-week consumption. With the acute results, I'm showing you only some of them for the sake of time. 1, we found that MTOR, do you remember what MTOR does? It promotes muscle protein synthesis. It went up by 5 times in the muscle. So give a load of MTOR, take a biopsy of give a load of Stronghold, take a biopsy of the muscle compared to the placebo, and we found that MTOR activation went up by 5 times. Huge increase in MTOR. Now, what about glucose and insulin? No change whatsoever. Glucose and insulin stayed rock steady throughout that time point, these time points, which is nice. What about GLP-1? That has become such a point of focus. We found that at that end point, not the area under the curve, which is what I showed to the right, but that end point, the final point of the GLP-1 was more than twice the level with Stronghold consumption. And that's because protein and some amino acids do activate GLP-1. It induces that production from the gut. Okay, now what about the chronic results? So, very important, we found that, firstly, that the branched chain amino acids in the plasma were significantly down. Now, that is important how I'm describing it. I'm saying the branched chain amino acids in the plasma. That is used, and this is in a fasted state. So it's not like they just ate the Stronghold. This is in a fasted state, nothing having been consumed for hours. The lower BCAAs, the lower branched chain amino acids, means less proteolysis. This is proof positive that the muscles are holding on to their protein rather than breaking down. So very strong evidence of an anti-catabolic signal or improved anabolic signaling, or in other words, less anabolic resistance. So pretty dynamite finding, frankly. And then we looked at tissue mass. A significant increase in muscle at a very fine level, milligrams of muscle mass, but also a reduction in fat mass as well. Pretty favorable changes for a person who is trying to improve their metabolic health. Now, one final thing, I told you earlier I was actually going to show you what muscle would look like. This is under a light microscope. And what we're doing here in this image from a muscle tissue sample is looking, remember I said how muscle is in fibers, long little tubes? What we're doing is looking down the tubes. So we took a long muscle and made a slice, a microscopic slice. So we're looking down the lengths of the muscle, and you can see on the right, Stronghold resulted in significant increases in the cross-sectional area. That's what we measured, the cross-sectional area of the muscle fibers. So muscle fibers that were a lot bigger than they were in the control group. In conclusion, my darling students, you now have a very good appreciation, not only a reminder, if you will, of insulin resistance, but now a very strong understanding of how anabolic resistance can be an enemy that is not only compromising quality of life. As muscle mass goes down, so too does what we can do with our bodies. Muscle is, after all, the strings that manipulate the body, move us around. But also its role, how maintaining muscle helps maintain optimal metabolic health by keeping insulin resistance at bay. And we've long, within Unicity, been talking about that metabolic side of insulin resistance. Now we can step into the muscle much more seriously than we have before, and perhaps more seriously than anyone else is talking about this the same. So the two resistances, insulin resistance, anabolic resistance, and now you're armed with some pretty effective tools to help your friends and family address both. And may we all be good examples of people who actually know what we're talking about. Thanks for listening. Thanks very much. Thank you very much. I was really long-winded, but I think I may have a little time for Q&A. Rav, Trent, yes? I don't know how it's going to work, though. So I'm going to stand here and look really pretty until someone tells me what to do. Dallin says we have 3 questions, and I think the mics will float around.
With Stronghold, are you seeing a difference compared to just taking creatine on its own? Like, is it a completely novel, new product?
Yeah. So there's nothing novel about creatine, other than the fact is, frankly, most of the people you talk to might not have even heard of it before if they're not involved, or they may think that it's just for the athlete who wants to run a faster 100-meter sprint. So we have included the best type of creatine in a nice amount, but when it comes to we have enough for muscle, but those of you who want more of the cognitive, I would say add a little bit in.
How much?
Yeah, it depends on what type you're... No, that's a good question. 5 grams.
Thank you.
Mm-hmm. Yeah. I can't see anything, by the way.
Hi, Dr. Bikman.
It's so bright, so you're all just a beautiful mass of dark nothing. So I'm not even going to look at you when you're... Okay, I see a hand. Yeah, okay.
Here, over. I'm a huge fan, but you said when we do the chlorogenic acid, and if we did the Stronghold with it, that actually decreases the chlorogenic acid. Is that if you take them at different times of the day? Or
No. That's if you are like doing that, like the alchemy in a cup. We are taking, hello, my little friend of Unimate, hello, friend of Stronghold, play nice together. They don't. So I mean if you're taking it concurrently.
Okay. Was there any issue with doing the balance with the Stronghold since I had it mine?
No. Mm-mm. No, not at all. But yeah, I actually worried. I don't want you guys to take that one slide and blow it out of proportion. I always want to err on the side of teaching you something. And because I know some people are mixing, I just thought you'd find it interesting. The degree to which you get worried about it will be up to you. I personally do not mix them. I want them both separate. Actually, frankly, part of it is simply I like the flavor of each, and I want to enjoy a different flavor at a different time of the day.
Dr. Bikman?
I can't see anything, so you guys just pass the mic around. Okay. Okay, I see a hand, yeah.
Yeah, thanks again for your talk. A lot of times we look at people who want the taste, and sometimes we sweeten it with sucralose, sometimes we sweeten it with stevia. Is there a big difference in why we do one or the other? Because some people are against the sucralose.
Yeah, that's a great question. One thing that I just love about Unicity is we're never content when it comes to the science. And if there's something that is suggesting that what we'd done previously could be improved upon, then we do. And that case in point is replacing sucralose with stevia glycoside. Stevia is better, and I'm thrilled to see us making that change. Yeah.
All right, Dr. Bikman, Coach
Oh,
Hoyt.
Trent. Oh, sorry. Oh, yeah, please.
Coach Hoyt, how you doing, man? So a lot of the athletes are concerned about the creatine because it creates like a fibrous muscle. Have you seen that with the muscle being stronger with that? Because the athletes are concerned about that with the creatine.
Sorry, can you say that again?
Sure. So a lot of athletes are concerned about the creatine because it makes the muscle more porous, so a lot more injuries. Have you seen?
Not true.
Not true?
Absolutely not true. No, creatine will do nothing to the muscle membrane. It absolutely will not make it more porous. They may say that, like the bro science may say the cell is more porous because where you have more creatine, you will have more water. But that in no way actually reflects a lack of integrity of the muscle membrane. That is absolute false.
Thank you.
But creatine will promote muscle water retention. So if the main priority, which I think Trent has a question, Trent wants to have his muscles juicy for the pictures taking on in your Speedo.
That's right.
Creatine is part of it.
Thank you.
Yeah, and pass the mic. Yeah.
Dylan said last one right here.
When you say superior protein,
Yeah.
why did you choose whey protein versus all the other different types of protein?
Yeah.
Why whey?
Yeah, so the only two, if I were like master of everything that Unicity did, I would say we can only choose one of two proteins. It would be whey or beef, because everything else is inferior. And that's, in fact, what that study tested. They took a plant-based protein and compared it to an animal-based protein, and you see the differences are enormous. The blood amino acids went up by double, and the muscle protein synthesis went up by 47%. So that is a topic that some people might not like because they have their own ideas about nutrition. But let me clarify what that study said and what I stated at the time when I shared it with you. A young teenager or someone in their 20s can get away with any protein. It won't matter. They're so anabolically sensitive. But I'm talking specifically about anabolic resistance. The harder it is for our bodies to convert dietary protein into muscle protein, the easier we want to make it. And so let's not waste time on an inferior protein. So we picked the best.
Ben, I need more muscle.
Hey, brother. Yeah.
And
I've heard, in fact.
So I'm gonna ask you a couple rapid fire questions. Number one, is it possible to have too much Stronghold? Could I have 4 to 6 packets a day if I'm trying to get 10 to 15 grams of creatine through Stronghold?
No, there's no overdosing. All of these things are so normal. And it's maybe once upon a time, Trent, someone would say, well, that's a lot of creatine. But the whole conversation with creatine has changed so fantastically that you have people taking up to 20 grams, and there's no apparent problem with it. So no, maybe of everything. Like I wouldn't want to take 4 packs of Unimate because I'm already a terrible sleeper. I'm already kind of always turned on. And that would just be a little too much of a good thing. But with Stronghold, no.
Awesome.
There's no problem.
You mentioned that the glucose and insulin remained unchanged. I believe that was in a fasted state.
Yeah.
Does that mean that if I am in my fast and I take Stronghold, we always say, if it's more than like 15 calories or so, you're technically kind of breaking your fast. Would you say that Stronghold breaks a fast in a way that we should be
love that
measurably
question.
interested in?
I love that question. So there are, this is a good one to end on. Dallin, are we, okay. My view on fasting is more complicated than most of the thermodynamic calorie purists would like. So I actually think there are 2 types of fasts. There's a caloric fast, then there's a metabolic fast. And I'll explain them in just a second, but what they both have in common is that one powerful yet petite little hormone is down. Can you guess what that hormone is? Insulin. Insulin, Dr. George Cahill. If I could have anyone come and replace me at this very moment, it would be our dearly departed Dr. George Cahill. He is one of my absolute heroes. He once said, and he was a fasting scientist, or what they called at the time, a starvation scientist. He said, insulin is the hormone of the fed state. Thus, anytime insulin is low, you're in a fasted state. And as far as the body is concerned, Trent, if you were taking in calories, someone on the caloric fast side would say, oh, you're breaking your fast, and yet no single blood marker or tissue marker would suggest you were not fasting. In other words, to say that all double negative in a more correct way, your body would look like it's still fasting. That's the metabolic fast. So if you look at all of the metabolic markers and the biochemistry and the signaling, it wouldn't know that something had come in, that calories had come in. Because they would say, well, after all, the protein from the protein in Stronghold is some calories. But even then, you guys, the body does not burn protein for fuel. It uses protein for structure. It is an extraordinary set of circumstances for the body to actually burn protein. It doesn't happen. It burns fats and glucose, or ketones and lactate, etc., but not protein. So, are you in a fasted state? Well, the calorie guy would say no, but I say absolutely yes. And then I would say he doesn't even know what he's talking about. All right. Thank you, guys. That's a good question. Thanks so much. Thank you so much. I had a great time. Thank you. Thank you very much.